All right, we are live once again. But first, I'm going to notify everyone that we are. Just like that. And today we are going to set the foundation We're going to set the foundation of our market making algorithms because we are going to provide liquidity on our own exchange, on our own custom exchange. All right, let me quickly check. All right, it doesn't matter. Let's go. Let's start. So, I have some new setup. So if something is wrong with the stream, with the audio, let me know. So we have our exchange working. We have our JSON API, but I want to interact. If we want to make these market making algorithms, we actually want to have a client API to our own exchange, so we can actually place limit orders, cancel them, retrieve the order books, and all that shenanigans. So what I'm gonna do first is basically create a new folder. I'm gonna call it server. New file. Server.go. What is going on? Rename server go. All right, package server. And we're going to actually copy everything from main. Because we have the whole shenanigans, the whole server is in our main. We're going to move it. Something like this should work. And what is going on here? Let's open up the other side. It's a transfer eat. So that's basically in utils. What is this? Transfer eat, so we need to copy this function and put it into server real quick. Actually, we're gonna paste it in here, so that's working. We're gonna delete this util function. We don't folder, file, just like that, and then what is going on? That's good. Let's open up main. I think we have a function. Yeah. This is not good. So this is gonna be start server or something. What the hell? Still warming up. Still warming up. So start server, and then we can go to main and actually try this. So server. Start server. That should work. Let's try. Connection refused. Yeah, that's because we have our private Ethereum blockchain and we need to boot that thing up. So Ganesh -D for deterministic. So we have the same addresses as usual. Like this, and normally if we try to boot this thing up, it is working perfectly fine. Nice. That's one. The next thing we're gonna do is create a new folder. We're gonna call this client, where all our client logic to our own exchange is gonna house. I'm gonna call this client go. Package client. Let's open up in this window like this. So we're going to say client struct HTTP client new client And we can say something like HTTP default client. That should work. All right. So the first thing we're going to do is we're going to make an API. We're going to make a client function to place a limit order. So we're going to call this client place limit order. And we're going to return it. We're going to make it return an error for now. Yes, we should have some params. So how are we going to do this? If I can remember correctly, we can do something like request is going to be an HTTP new request. And what does a request take, by the way? A method URL, okay. HTTP method post. The URL. That's going to be HTTP localhost 3000. Order. So we're going to post to order. And now we need a body. If I remember correctly, we have something. Place order request. This is the thing we need, right? So this is what it expects from in a JSON serialized format. So we could do something just to test this. We could do params is place order request. Yeah. So we need to give it a user ID. Let's say 8. A type. It's going to be server, a limit order. A bit for now, we're going to say it's true. A size, let's give it some random size. And maybe a random price, just to test these things out. And the markets is going to be a market ETH, Ethereum, ethers. What's going on here? All right. Now we need to serialize this to a JSON byte array. We could actually do JSON Marshall params. We're going to return the error here. And then we're going to say, but because it needs a reader, we're going to say bytes new reader and the body. The errors, once again, copy this, paste it in here, and we're going to print out, maybe printf actually, verbose, direct. All right. Let's see if this is going to work. Main. So I'm going to, the problem is server start server basically blocks, right? It boots up our HTTP server and it's going to block. So I'm going to use Go. I'm going to use a Go routine to start this thing up. I'm going to time sleep. Let's say 1 second. Like this. Client is going to be a new client, server, no. Client, new client. if r is going to be the client place a limit order just like this, and then we're gonna panic this error out just for now. All right, so if it all goes well, we will place a limit order onto our own exchange. Let's try this, make a run. So it's doing something. Let's go to server to check. Place limit order is this thing here. So we could do something like log printf new limit order size 2f price. Wait, I'm gonna actually change this. Price is going to be 2f and the size is this. Man. And we're gonna say it's gonna be order limit price and the order size. All right, test. Uh-oh. Ah, I know what the problem is. Client. So this is a request, right? What we need to do is say client. Is this an error? Probably it is. If r do the request. Yeah. Return the error. Where is this? It returns two things, okay. Response, error. If the error is not nil, and then we're gonna say empty print f verbose the response. I'm gonna put this a little bit, drag this a little bit higher. Yep. All right, so yes, it's working. New limit order, the price and the size. And that's working out fine. All right, so now we need to make this function a little bit more cleaner. So let's go to client. We are in here already. Place limit order. We're going to say user ID. Sorry, I was distracted by some tabs. User ID. That's an N64. We need a price and a size. Basically float 64s, and then we can say there's a user ID. We also need to specify if this is going to be a bit or an ask. So bit bool size price. And actually, maybe we should make something like place limit order parens to make it more cleaner, to be honest. N64 bit, man, bool price float 64, and the same thing for size bit user ID. All good, all good. And then we're gonna say params, a pointer to this thing. Yeah. Params, user ID, bit, size and price. Okay, cool, cool, cool. And what is going on? Params, params. I see what's going on. So let's make it this P because we can. Wait, let's do this. Man, I'm a little bit rusty, I'm not gonna lie. Golang and his capitalized. All right. So now in main, params, client, place. What else going on? How did I call this? Place limit order params. Man, I have no clue what I'm doing. It's so I need to drink coffee right now. Your code is really clean. Good job. Thank you so much. I'm doing my best. I'm doing my best. Okay, cool. So what am I doing actually? Place limit order. Params. Client, place. And I have no idea why it's not type hinting. I have no clue. Place limit order params. User ID. You see, it's something is wrong and I have no clue what it is. Client. It is what it is. User ID 8. I'm gonna make this a pointer. Boom. Bit. And this Visual Studio Code key bindings, sometimes these Vim key bindings, bit true. We're gonna place a bit. The price 10K. Wait, I'm gonna do it like this. I should know that it's a float 64 to be honest. And the size 10 ETH. A matter of fact, it's gray. Anyway, it doesn't matter. And then params. Okay, this is place limit order params. Client type struct let's do some reorganization. Am I missing something? What the hell is going on? Type place limit order params. Yeah, it's public. It cannot be more public than that. So what the hell is going on? Oh, but I know what it's doing. It's doing HTTP shenanigans for some reason. Oh my goodness! Look at this. Okay, I see. So we're gonna say C. Classic Go shenanigans. So we're gonna say C, that's the client because reasons, and then This should be client. This should be client. Client. All right, cool. Make run. All right, this is working. And we can see here, these are basically 3 users that are sitting in the exchange at boot up. And they all have, I think, 1,000 ETH. And that's basically our Ganesh. I think it's the last 3 addresses. They are basically inside the exchange as users. So when they place a limit order and it's being matched by a market order, we are actually transferring ETH to these addresses like a real exchange, but on our private Ethereum blockchain, of course. And this stream is basically the building foundation so we can actually make our own market making algorithms. And that's the next series I'm going to launch, is basically the quantitative trading, because a lot of people want to know more about it. Because on YouTube you can find a lot of rookie tutorials that using EMAs and something like if the price is going above the 200 EMA, you need to buy, and if it goes below, you need to sell. That are no algorithms. That's that's literally trash, because these guys don't know anything more, right? So they do these rookie algorithms that actually don't work. And I'm going to teach you how it really works, all right? And actually, if you want to make an algorithm that's profitable, you only need to do arbitrage. That's the only thing that works. That's the only thing that works, right? Oh man, I'm stiff. I was training yesterday, chest and shoulders, man. Whew. All right. Place limit order, that's working. What I want to do is basically, when we place an order, I want to print out the order books. Actually, look, so I can do this, right? So I'm going to make run. So it's going to place an order. And let me quickly open up my Postman. Open Postman. Let me see that I don't show any disgusting pictures. All right, so workspaces. Get books. What the hell? When is Postman so complicated? Get book, eat, boom. Could not send. What the hell is going on? Ah, yeah, I know what's going on. We need to block. We need to block because I'm sending a request and our server is already down. So what we're going to do, a tip for if you basically want to block real quick is, oh man, all these tabs. Okay, cool. Is basically do this. Select, and then you do that. Boom. And call it a day. If we run now, it's basically going to block at that select, placing the order. And if you go to Postman and I do send, you see, we have this in our books. Let me open up this. Boom. This is our exchange. This is our JSON API. And I'm fetching the books, and we can see total bit volume is this 1,000 size. And the price limit is 10K. And it's a bit. And the user ID is 8. So it's all working fine. It's amazing. That's what we all have been done in the previous streams. So now I actually want to, but now that we have this Postman, should we? Nah, we can actually use Postman, why not? Okay, so what we're gonna do is, let me quickly check place limit order, this thing. So we're gonna do for something like this, right? Time sleep, 2 seconds maybe, or 1 second. Time second. Yes. So the price is 10K, right? So if I'm increasing the price, you know what? We're gonna do something. Go funk. Like this. And then bit params. I want to test if basically the matching engine is actually coded properly. A little stress test. Bit params. And then we're going to say ask params. User ID is going to be 8, why not? Bit is false. 8K because he's pessimistic. Ask params. Not sure what's going to happen, but we will see. Make run. All right, it's doing something. So let's open up the books and let's send us some requests. Oh yeah, oh yeah. So you see, it's basically providing liquidity. It's not a real algorithm. I know, but it's just testing the... holy shit, it's broken. Yeah, I was thinking. What the hell? This stack trace is insane. Race conditions. Race conditions. Of course, we didn't handle these. Race conditions. You can see... where was it? Yeah, round trip. Anyway. Concurrent, right. I saw this error somewhere. Anyway, it doesn't matter. So basically, what's the problem? If we open up the order book, we can see order book here. So we can see that we have a map. And what happens is that we are booting up a Go routine that's basically sending these bits every 1 second. And then we have another function that's basically sending these asks, and it's concurrently writing to the same map and reading, right? Because it's always checking what's inside of the map in our matching engine logic. And that's basically a problem. So how can I solve this? Normally, all these things are basically kind of single-threaded, right? And a real exchange works with a Kafka queue, right? The most of them work with Kafka, Apache Kafka. And they're processing these orders in a deterministic way. And we, not. So I can actually solve this very easily. And that's exactly what I'm going to do. So Um, async read write mutex. That should work. The question is, can I use 1 for 2? We will see. And now I need to check where I write these things and where I read these things because God damn it, this is going to be a pain in the ass. Actually, nah, it's too complex. We could also use something like goroutines and then communicate with a channel. Order book. Place limit order. Let me open up order book again so I can actually see what's inside of this thing. So this slice is no problem, right? Because we are only appending and we also deleting. How can I make this? OB bit limits is this thing. I'm gonna lock the whole shebang, to be honest. Unlock it here. Defer. Because all these other functions are new limit. Limit add order. I think we should be good if we place this lock here. But I don't think that placing the limit order was an issue with these functions. I think the problem is the API, the JSON API where we fetch it. So we are writing and then we are getting. It's basically this one, asks. No, it isn't. Anyway, I'm gonna try like this and see what's going on. And actually, what the hell's going on here? Let me open up main. No, it's server. No, it isn't. Yes, it is. It's client. Oh my god. This log, this thing, this really irritates me. Response. Never do this in production, please. Let's see if it's cleaner now. Wait, one more thing we didn't do is basically server. There can be a string. Order type. B, V. I don't know, what's bool? What's the format of bool? B, P, T, T. Is it T? I'll take it. All right, let's see what's going on. All right, so we're placing these bits and these asks, all good. So see, I don't think the issue of the data race is going to be the JSON API. So let me open up. So I'm basically spamming this volume. See, it's working right now. I think I fixed it. Hi, first-hand coder. How are you? What is poppin'? What is going on? Yeah, so it's working. That's good. So we see that the bit volume and the ask volume is incrementing. That's good. Fixed. Fixed for now. Fixed for now. Good. Okay. Placing limit orders, check. Now we need to cancel it. Very important. If you want to make those algorithms, market maker algorithms, it's very important that we can cancel the order. It's crucial because they place basically a bit, they place an ask with a straddle. And if the price is not going into the direction, or the price is moving too fast or whatever, they need to instantly cancel, right? So they place, cancel, place, cancel, place, cancel. That's what they do. So cancel order. Luckily, we have this already, but not in our client. Client cancel order. The question is, what does it return? Order book. Cancel. Order book. Cancel order. It needs an ID, an order ID. So basically what we also need to do, so if we want to cancel an order, we need an ID. So if we place an order, it should actually return the order ID. And we don't have that, so we're going to say maybe we could do something like N64 error. And I really hate this because right now we need to say something like 0 error, right? Look at this ugly thing, 0 error. And I don't like it. It doesn't make any sense. So if I come in my code and I don't have the, let's say I don't see this, right? Let's say this is gone and I come in my code and I see return 0 error. Me as a developer, new to the code base, what the hell is going on? I have no clue. So what I'm gonna do is I'm gonna make place I can do place order, right? Place order response and for now we're just gonna say it's the order ID. int64. And now what we can do is, instead of this ugly int, we can return a pointer to this place order response. And then we can say no. And that's basically much more clear, right? What is the response of place handle place order, handle place limit order? Handle place order, this is the main thing. This is for market. And this is for limit. Limit order placed. This is a garbage response. So we're going to say an order ID. That's what we're going to return. It's that easy. Man, this is... Wait, because there are so many functions that I need to take care of. So we return this ID. So yeah. Then we can go. Actually, I'm gonna do. You know what? Thanks for adding comments. You're welcome. You should remind me of this much more. Because normally, yeah, especially when this code is... You're right. I'm trying to bullshit myself out of the situation. But you're right. I need to comment these things more. And I will. When it's complex, I will. Yeah, so this thing, we're gonna move this up. So place order response, because then we can say, so we can say that the response is going to be and place order response, right? And the order ID is going to be the order ID, and then can we do this? That's the question. And then what we can do is do the same thing and say server. So this is the response. And we can say I'm gonna call it R. I don't know, because we need I'm thinking about good variable names. Place order response. That's going to be a server. What the hell? Place order response. Yeah. then we're going to say if r JSON new decoder response body decode the placeholder response. If the error is not null, we will return. What's going on with this keyboard? Crumbles. I was eating cookies and now the crumbles are on my hands. We're gonna return nil error. And then we return basically this thing, right? Placeholder response. Oh. And no error. And if this works from the first time, we're gonna celebrate. Not quite sure what's going to happen, but we will see. Okay, this will return a response. The same thing here, right? What can we... I'm thinking how we can handle this thing. For now, we're going to say maybe printf or println. Order ID. Okay, something is going on. Place limit order. Okay, server print place order response, yes. Yes. So what is going on then? Declare but not used. Oh yeah, it's, oh man, this. All right. And then we're gonna say the same thing, viewing this, paste in here, but we need to change this to asks. Boom. And then we delete this. Maybe. Hey. Beautiful. It's amazing. All right. That's working. Sometimes things work from the first time. It happens not that often, but sometimes it works and you need to embrace that moment. So what we're gonna do is we're gonna place an order to test or cancel order. And so we're gonna place one and we're gonna cancel one just to check if it works. So let me open up client. So first-hand coder, can you tell me what the quality of the stream is? I mean, with the bitrate and everything, is everything okay? Sound, font size, whatever, webcam, border size. Just tell me, give me feedback so I can change it to your belongings, believings, or whatever you say that, to your needs. Because I have these random YouTube streaming settings. Random, just I picked something random. Cancel order. What do we need is an ID, right? You could say order ID in 64. Awesome streaming. Okay, cool. Thanks, firsthand. He's gonna be endpoint, and I have no clue. I think it's a delete. How can I delete order ID? Oh boy. Okay, we're gonna do this fmt. I think it's s printf, not sure. It's gonna be order this d s, and it's gonna be endpoint order ID, and then we say I'm gonna copy the shenanigans. I don't think we need a body. Maybe we could do something like mop reader. Anyway, it doesn't matter. No. Response, Actually, we don't care about the response, to be honest. Or do we? Maybe if it's a bad error code, we could actually handle the response, why not? Yeah. I have no hair and I'm still itchy. Can you imagine? So cancel order, and then we do the request, and it should be all good. I think. Yes, let's test. So, wait, what we could do actually is to make sure we have some cancel order. And here we need to be careful with race conditions once again, because we're placing these orders and then we are reading from the GET request to get the books. So if we then want to cancel it, then we could come into some trouble. But first of all, I'm gonna log this thing out. My break is over. I have to go back to work. I have subscribed. I'll see you later. Thanks, First Hand Coder. Thanks for being a part of this amazing team, and I'll see you in the next one. Happy coding on your work. Cheers, cheers. Cancel order, right? I'm gonna say order cancelled. ID. Yeah. Main. If r cancel order response order ID nil. You can panic actually. Alright, let's see if this is working. I have no clue. Probably some race conditions. Method not allowed. Holy crap. Oh yeah, method post. That's not good. Copy pasting is not always the best idea, but sometimes we need to do. Or cancelled. Okay, so we're placing it, we cancel it, so we actually do not read from the same map entry. And we actually lock already. But right now, I'm going to fetch the books. Okay, so that's, you see that's working, right? So the bits are being canceled, you see, because we're placing bits, boom, boom, but there is no volume. That's because we're canceling them. And the asks basically keeps providing liquidity, which is good because we don't cancel the asks. Damn, this is actually working amazing. I like it. I like it. Let me quickly check. All right. The next thing. I'm going to drink. I'm thirsty. Oh, wait. I forgot I still have coffee. Delicious. All right. Okay, cool. So we can place limit orders. We can cancel them. It would be nice. So everything basically already works on the JSON. If we post it with Postman, we can place market orders, limit orders, do all that good stuff. But if we wanna make those market making algorithms, we need to have the ability to make a client so we can interact with the exchange through code. So there's only one thing we need to do, and that's, well, there are a couple things, but the first prior thing to do is create market orders. So let's do this here. Client. Oi, yo. That's place market order. Should we actually? Yeah, why not? I was thinking, can we not reuse the same place limit order params? Where is this thing? What the hell's going on? Place limit order params. What the hell is going on? Wait, I have a better idea. So if we go to this thing and we do GD, boom. Oh, it's in client. Okay, I see. Because the only thing that is different between a limit order and a market order is basically the price, because a market order has no price. Because it always gets executed at the best ask or bid price. So we could say, actually use the same thing. Wait, because this is getting complete. I'm reusing all these. Okay, cool. Let's take the same thing. It doesn't matter. Place market order. P, place limit order params. I'm gonna change this, by the way. I'm gonna change this. Place order params. Params. Now we can say price only needed for placing limit orders. Yeah, something like this. And then we can say place order params. And we're gonna clean this up for sure. I mean, but first make it work, and then we make it better, and then we make it fast. That's the circle of success. Okay. So what we're gonna do is we are going to copy this whole thing, actually. Yeah. Copy the whole shebang. Price needs to be away. This should be a market order. We hard-coded market ETH because we only do ETH right now. Ethereum, Ethers, Gwei, whatever. It's the same request. And actually this could be in the same function, I'm not gonna lie. I'm not gonna lie, but for the sake of... I have a better idea actually. So place order response. I'm first gonna test this and then we're gonna refactor it a little bit. So this should work perfectly fine, to be honest. Place order params. Okay, so what we're gonna do to test this is we're gonna place a limit order. We're gonna place an ask or bid as a limit, providing liquidity, and then we come in with a market order, and we're gonna match them. We're gonna match them. So we're gonna delete the shenanigans. I'm gonna delete everything actually. I'm gonna set this in a loop. I'm gonna time sleep 1 second. Like this. Bit params. I'm gonna call this limit params. User ID is 8, and I need to check in my main, no, in the server, what kind of user IDs we actually have. Because these user IDs are tied to a wallet. Very important. They are tied to a hot wallet. Because if we give a user ID that doesn't exist, we cannot transfer our currency. So we have 8 and we have 7. Okay, cool. And this can be 8. It's fine. I'm gonna place a bit. Sure. No. Yeah. Let's sell. Let's sell. false. 10K, and then let's do this. I can do 1 million, right? But that's 1 million gray, right? That's not ethers. Okay. All right, and I'm gonna say response error is the client place a limit order per rams. If there is an error, we're gonna panic like this, and then okay, that's this. Now we need to place a market order. Limit order per market order. Let me see. Market order per rams is going to be the same shenanigans. No price. The size is going to be the same size. It doesn't matter. User ID 7. Market order like this is going to be market order per rams. What is this? Probably this. Yeah. So placed a limit order, there's going to be placed a market order from the client. And the response for a market order should be different, I think. Because with a market order, we're going to match. So it should return the matches. So if all goes well, we place a limit. And this should be a bid. Because this guy is selling at price level 10K, 1 million fractions of Ethereum. And then user 7 is going to buy the whole shebang. All right? You don't care. Oh, it's still going, man. Look at this. How many volume is in this? Holy crap. FTX. Let's go. Make run. Let's see what's going on. Let's see what is popping. Yeah, the market order doesn't respond. I know. We need to fix that, but I think that the books are empty, and that's perfectly fine. Why? Because we place an order and we fill it. We place an order and we fill it with two different clients. And if we want to be 100% sure if this is working, we can stop this. We can go to our... look at this. Look at this guy. So look at this, what happened, right? So what I'm going to make sure, this is our blockchain. So I'm going to boot it up again, make run, and you can see, boom, it's placing these transactions, bam. Insane. We have an exchange. Where are you going to learn these things? Nowhere, never. It's only here. It's only here in my channel. Nobody's doing these things. It's amazing. So he's placing an ask, a market order comes in, it is being filled, we send the Ethereums. That's how it goes. That's how it works. So, and we can check this, right? You can see if we start this again real quick, make run, and I'm gonna stop it, you can see that the balance of these guys are different, right? Because we are sending these Ethereums, these fractions over. And I really want to send like 1 ETH, but the problem is we are working with float 64s. Actually, we are working with float 64s, and I cannot fit that in. I cannot fit such a big number inside of that thing, in that space. It's only 8 bytes, and we need more, 256 to be precise. But that's for later on. That are minor things. Right now we are sending smaller values. It doesn't matter. Okay, we have an issue, and that's basically in server, I think. But if I place a market order, I'm 100% sure it's getting filled, so why do I need an ID? Handle place order. Okay, this is that. So what we can do is actually copy this. We don't need these matches. We don't care, actually. We don't match orders, do we? Handle matches. Matched orders. I really don't care, to be honest. So we have the matches. We handle the matches. And then we do this, and we can. So basically it comes into place limit order. We do our stuff. This will not be triggered, and we do this. Cool. If we come in market, if it's a market order, we don't do this. We come here, and then we do this. That should work fine. Let's test. So now we should actually have yes. So what we can do is go to server. I think, or maybe order book actually. Place limit order. Are we printing this out here? Nope. Okay, we're printing that in. All right. So now we go to place market order, and we're gonna do the same. And we're gonna say, let's close all the shenanigans. Give us some breathing room. We are gonna print out filled market order. There's gonna be D size 2F, right? 2F. Come on. Help, please, Visual Studio, what's going on? Come on, man. It's not and this is not the first time this happens. Why am I in order book? It's this Vim plugin, man. And I'm confused. Where the am I? And now I'm confused as fuck. I was in server, right? I was here. Filled market order. This will be the order ID with, yeah, it's going to be clear enough. 2F. That's going to be the size. And then we're going to say order ID and I think matches. Yeah, the order has always been filled, right? So we can just say order size, right? Order.size. It should work. Make run. So, and I'm gonna delete our client code, to be honest, or client logging, because it's confusing me. Response, just like that. All right, so we place a new limit order. Filled market order. All right, there's something is wrong with the, of course, the size is wrong because the size it's filled, so the size is 0. That's true. That's true. That's true. We need to fix that. All right, how can we fix this? That's a good question. Come on, OBS. Yes, cool. I think it's in server, right? Yeah. So why is the size 0? Because we're actually subtracting. Each time we match, we subtract until the order size, because it's a pointer, we can modify the value in memory. So, oh man, how can we... So we could do something like a total size filled, which is going to be 0. And then we say total size filled. What's going on here? It's going to be matches I size filled, I guess. And then we can say market order filled, so that's size, and then we can say total size filled. No. Total size filled. All right. Is this working? Yes. Okay. And now we can make it a little bit more spicy. Actually, the first thing I'm going to do is quickly, and let me check how many. Doesn't matter. I would say I'm going to take a little toilet break, but it is what it is. We're going to make it more spicy. How are we going to do this? Is by making multiple limit orders, providing liquidity with multiple clients, multiple user IDs, and make the size a little bit smaller. So basically the market order will eat 2 orders, will fill 2 orders, 2 limit orders. That's what we're going to try. And then see at speed how the order book, how the matching engine, and how our blockchain is interacting. And if it all goes well, we are in a good spot. And then we can transform into our market making algorithms. How do they work? And I was thinking maybe I should do this series, the market making algorithm series, into Python. But that's something you guys need to choose. I don't really care. It all depends on what you want to learn and in what language you want to see this. I'm your slave. Okay, so limit order params. All right, so other limit order params, and then this error, we don't care. It's going to be a user ID server, actually. Where is this thing? Eight, 7, and 666. That's the number of the devil. User ID 666, right? So I'm gonna make this. This user is gonna put the price one lower. It's gonna put the price level at 9K, and we're gonna make it half a mil, and this the same, half a milli, like this. Okay, I'm gonna quickly test this. I'm gonna remove this market order real quick. I'm gonna comment it out. How do we do this in Windows? I have no clue. Oh, it's control. Okay, cool. Normally I'm a Mac user, but for streaming, my Mac is too old. So I'm using this Razer Blade 17 with an insane GPU. Okay, cool. Let's run this, and it should place 2 market orders, limit orders at 2 different price levels. And let's open up our exchange. Yeah, okay, it's working perfectly fine. Okay, that's very good. So now we can actually put this market order inside. So what should happen is we are placing 2 limit orders into our books, into the exchange. They both have 500,000 as size. One is at 10K and the other one is at 9K. Then we're going to place a market order, which basically will be filled for 500,000 on 9K and 500,000 on 10K price level. That's how it should work. And if this works, then we are in a good spot. Yeah. And it's working, actually. Let me see. This should be empty. The book should be empty. Books are empty. Because there is no liquidity, right? Because 2 guys are placing orders, and then this one chat is buying the whole exchange. And it's all working fine. Nice. Cool, 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 cool. One thing we should actually do is, if so this market order gets filled by 2 different price levels, so we should actually return what the average price was we are filled with. Filled market order size. So we could do like, I have no clue what I'm doing actually. Actually, you could do like some price, something like this. Some price. Some price matches y price. And then we do, I have actually no clue if that's correct, but hey, trial and error. We could do some price divided by len matches. Is that a thing? Float to 64 type languages. Yo. Average price, yeah, why not? It's gonna be the same thing. 2f, right? Yeah, I have no clue. Yeah, it's easy, right? It's no big of a deal. So the average price 9,000. If I buy at 9, I buy at 10. So I actually averaged out at 9.5, right? Ish. Yeah. Cool. So I think we have all the building blocks we need, and then the next stream we can actually implement our own market making algorithms. And we are not going to do, like I mentioned before, we are not going to make these trading algorithms where we check the 200 or the 20 MA and the 20 EMA, and if it's above, we're going to buy, and if it's below, we're going to sell. And I mean, that are no algorithms, right? That's dog shit. That's literally garbage. But it's unfortunately the only thing you see on YouTube because nobody has a clue what he's doing. And we know, and I'm going to learn you exactly how these algorithms work. Because we need it. We're going to provide liquidity on our exchange. All right. So are there any more questions? If there are any more questions, please feel free to ask me, and I'm happy to resolve them. And in the meanwhile, our private blockchain is going ham, sending all these transactions. Oh, it stopped. Oh no, it isn't. Noise. What we also need to do is basically get the fees. The exchange fee, the house, because the house always wins, right? So we need to do that also, but that's no big of a deal. All right. If there are no more questions, I would thank everybody that's watching this stream. I would thank everybody that was a part of this amazing team. Like I mentioned, if you have more questions later on, if you view this video later on, you can always DM me, or you can always find me on Twitter, or you can put your question in the comment, or you can actually join my Discord community, which is basically a fresh community I'm trying to build where I'm going to help you to be a much better engineer, especially in blockchain, DeFi, crypto, quantitative trading, and all that good stuff. So yeah, thanks for watching, and I'll see you in one of my next live streams and videos. Bye-bye.